Okay. So there's one final thing that I want to do today, and then I think we're in a good position for next week. Okay. The final thing that I want to talk about is something called stationary points. Stationary points. Okay. So, okay, fine. So, a stationary point. What does the word stationary mean? What does the word stationary mean? Yeah, it could mean that. It just means not changing. Yeah, so constant is fine. Okay. Be careful how you spell it, because there is another word in English. If you change the A here for an E, it means like stationary, as in like pens and pencils and staplers and stuff like that. Yeah. So stationary with an A means you're not moving. It means you're not changing. Okay. So what I'm asking for about stationary points is find me the point where the gradient is not changing. Okay. That's all it is. Right. So let's think about this. I've got a graph here. Okay, y equals 3x, is it 3x cubed? Sorry, 3x squared. Good job I checked. 3x squared minus 12x. 3x squared minus 12x. So I know that it's going to look something like this. Okay. Yeah. Is it like that? Yeah, it's going to look something like that. Okay, so this is the graph. This is the graph of y equals 3x squared minus 12x. Okay. Now what I'm looking for is a point, and the point has to be stationary. In other words, the gradient of that point is not changing. Where is that point?
When you touch the minimum of the curve.
Exactly. Okay. So it's the point which is at the minimum. In other words, this point down here. Because if I draw the gradient line in, the tangent line in at that point, are you happy it's completely flat? It's completely flat. So in other words, the gradient of that flat line is just zero. Exactly. And that makes sense, because we said that stationary means that it's not changing. In other words, the rate of change has to be zero. If it's not changing, the rate of change is zero. Yeah? So therefore, at this point here, the gradient is equal to 0. Does that make sense to everyone? Okay, good. So let's find the stationary point of this curve here. Okay, we could do it just by looking at it, inspecting this, and knowing that the turning point, the minimum point, has to be halfway between those two. But let's do it through differentiation, because sometimes we might not be able to see what the curve looks like. Okay, let's do it through differentiation. So first things first, I need to find the gradient function. What is it of this curve? Y equals 3x squared minus 12x. What is the gradient function? Minus 12. Good, exactly. Now I'm after the stationary point, so I'm going to call it SP for short. Okay. Now I know that the stationary point is when the gradient is equal to 0. Okay. Well, look, this is my gradient function. 6x minus 12, that's my gradient function. So I'm just simply looking for the point when that thing is 0. Where is that point? How can I solve this? Yeah, I add 12 to both sides, divide both sides by 6, just solving that linear equation. Are we happy with that? Yeah? So I know that my x-coordinate has to be 2. But remember, I want a stationary point, which means I also need a corresponding y as well. Okay, so if x equals 2, how could I find a y? Absolutely. Once I have an x-coordinate, I have a function, I have an equation, which links together every x and y coordinate. It's this one here. This one literally says, you give me the x-coordinate, and I will tell you what the corresponding y-coordinate is. Okay? So if x equals 2, it means that y has got to be equal to 3 times by 2 squared minus 12 multiplied by 2. Are you all happy with that? Okay, so let's work it out. So 3 times 4 minus 12 times 2, that's 24. So I get 12 minus 24, that's going to be equal to negative 12. You all happy with that? Okay, good. So therefore my stationary point is going to be 2, negative 12. Is that okay? Any questions? So let's have a look. So first things first, we want to find the stationary points. Okay. So what's the first thing we need to do? Okay, so we need to differentiate this thing. So come on then, if we differentiate, what do we get?
3x squared plus 6x minus 9.
Cool, excellent. Now, we know that a stationary point occurs when what? What condition is met?
Equal gradient.
Good, when the gradient is 0, the rate of change is 0. Okay, this is our rate of change, 3x squared plus 6x minus 9. So if we set that equal to 0, that's the equation we need to solve. Okay, so is there anything we can do to simplify things?
Wait
Yeah.
a second. This is like x minus 3 squared, right?
What?
Sorry, that's it.
Okay.
I made an ass of myself.
So yeah, you notice that everything has a factor of 3 in. So if you divide through by a factor of 3, you get x squared plus 2x minus 3, and 0 divided by 3 is still 0. Okay, so it's a slightly easier equation to solve. This is just a quadratic. You're happy you can just factorize this into 2 brackets. So you start an x and an x, that's what's going to give you your x squared. Then you're looking for 2 numbers to multiply together to make negative 3, that one, and which add together to make 2. So what 2 numbers multiply together to make negative 3 and add together to make 2? And positive 3. Cool. Okay. Which then means that my 2 roots are going to be what? Yeah, are you happy with that? Because what you're basically saying there is you've got 2 numbers, you're multiplying them together, and they make 0. The only way that can happen is if one of those numbers is 0. So either this one, x minus 1 is equal to 0, which means that x has to be 1, or x plus 3 has to be 0, which means that x has to equal negative 3. Okay. If you've got any issues with solving quadratics, again, online I've got videos with how to solve those, so go and have a look at those. Okay. So this is weird. Before, over here, we just had 1 point. How many points do we have now? 2. Okay. By the way, we also need to find the corresponding y's. Okay. So you find the corresponding y coordinates by sticking this x coordinate into your original equation. Okay. So if x equals 1, you should get y is equal to what? 2. Okay. And if x equals negative 3, what does y equal?
34?
Is it 34?
I don't know.
Okay, so we get negative 27 plus 3 times 9, which is 27, so that's 0. That's nice. Sorry, is it? What'd you get?
I guess 34.
34 as well? I'll take that. Yeah, it is 34. Cool, thank you. Okay, which means that my my 2 stationary points are going to be 1, 2, or negative 3, 34. Okay, negative 3, 34. Now just pause for a second. Let me create some space. Okay, have a look. Have a look. Before we were just having 1 stationary point. This is a cubic curve. What's the shape of a cubic curve?
What was it? Like something like this? Or
Yeah, it's like the Loch Ness monster. Okay, okay. Or dragon or something like that. Okay, fine. Which means that we are expecting 2 stationary points. We've got 1 here, and we've got 1 here. It's literally the turning point of the curve. Literally the turning point. Okay. So this point here is going to be negative 334. This point here is going to be 1, 2. Now have a look. Have a look. With this curve here, with my quadratic curve, which I started off with, we said that was a minimum. Okay. But it's not just a minimum. Would you be happy that it is a global minimum? Okay. Whereas here we have both a minimum and a maximum. So over here we've got a maximum, and over here we've got a minimum. But they're not global, they are local.